Okay, so here's a controversial question. Should you teach math in a student's native language, or should you teach just in English? You think the answer is obvious, right? Just teach them in the language they actually understand. But here's what actually happened when researchers in Ghana tested this directly. They compared 3 groups of students. One taught only in English, one taught only in Tree, their mother tongue, and one taught in both. And the results, they're not what anyone really expected. This study comes from St. Joseph Senior High Technical School in the Bekwai Municipality of Ghana. 3 classes of students, same teachers, same material, same length of time, but different approach to the language used in the class. Group 1 is what we researchers call the control group. This class was taught entirely in English. That's what Ghana's official policy requires, everything in English. Group 2, the treatment class number 1, was taught entirely in Tree, their native language. No English at all. In the last group, Group 3, treatment class 2, was taught in both Tree and English together. Mother tongue as a supplementary tool, not the main thing. Then they gave all 3 groups a math test before the instruction started and the same test at the end. Although I would use a different form of assessment, nonetheless, this standardized instrument is what the researchers decided to use, so they used it. The question was simple: which approach actually works?
So this video is sponsored by Need the Tea. It's a nice brand that has words in a circle, nice messages, meaningful messages, and anytime you come next to somebody and they see your t-shirt, the first thing they do is so they can read it. So shout out to Need the Tea. Just go to needthetee.com, needthetee.com, and go copy one.
Let me walk you through what they found, because each result tells a different story. First, let's look at the English-only class, the majority of Ghanaian student experience. The mean score of the pre-test was 12.22 out of 20 points, and the mean score of the post-test was 13.13 out of 20. That's a gain of less than 1 point. And here's the key part. Statistically, the difference wasn't significant. The p-value was 0.070, close but above the threshold of 0.05. Translation: teaching only in English didn't produce a real improvement in math achievement. The students didn't learn more. They just, quite frankly, got a little bit older. In the second classroom, where students only used Tree, the mother tongue of the students, the mean score of the pre-test was 13.52 out of 20. And the mean score of the post-test was 12.96 out of 20. When I read the paper, I said, wait, how'd they score lower than the English class? To even more amazement, how did their mean scores from pre to post move in the negative direction? Although slightly, just 0.56 points, still negative. How? Statistically speaking, the p-value was 0.518. which meant this was also not statistically significant. So teaching only Tree didn't work either. So, neither pure English or Tree. Neither of the two worked separately. Both approaches were statistically equally ineffective. The last class, Treatment Group 2. This group used Tree as an additional medium to English instruction, and the mean score of the pre-test was 9.83 out of 20, and the mean score of the post-test was 12.79 out of 20. That's a gain of about 3 points, the most of any class seen so far, and this is good, but the final piece of the puzzle is the pesky statistical significance. Well, the p-value for this group was 0, statistically significant. This was the only group that showed meaningful, measurable improvement in math achievement, both statistically speaking and numerically on the pre-post tests. So here's what the data is saying. Teaching math in both languages using tree to support understanding while building English proficiency works. Teaching in only one language, whether it's English or tree, doesn't produce significant gains. So I went into this research expecting the mother tongue instruction would be a game changer. I think everybody would have thought that. That if you just teach in tree, students would naturally understand the math better. But that's not what happened. And I think there's something really important here that goes against a lot of education advocacy right now. The advocacy says, teach the language the students know. It's more equitable. Students learn better. All that sounds right. It makes intuitive sense. But this research shows that pure mother tongue instruction, at least for secondary mathematics, doesn't actually deliver. At least not in this context. Here's what I think is actually happening. Mathematics has a specific relationship with language. It's not just about understanding concepts in a native language. It's also about being able to build a technical vocabulary in the language of instruction, because that's the language they'll use to communicate their ideas, take tests, and eventually use the math in the broader global ecosystem. If the teaching of the math is only in tree or just in one language, you're solving one problem, the comprehension problem, but you're creating another. Students don't develop fluency in expressing mathematical ideas in English, which is the language of their exams, their higher education, their professional lives. What does work is both. Use tree to explain the concepts, let students understand what actually is happening in the mathematics, but also use English so they're building that technical vocabulary while they're learning the concepts. It's like the Algebra Project says. They're developing students to be able to read and write using the principal symbol systems of mathematics. How do you ask? Well, they allow and encourage the students to use their own everyday experiences and people talk to reach that principal symbol system. It's not either or, it's both and. And I think that's a really important finding because it's more nuanced than a lot of the mother tongue advocacy is out there right now. It's not saying abandon English. It's saying don't make students choose between understanding and communication. So let me name what this research actually challenges. Myth number 1. If we just teach the mother tongue, achievement will improve. What the research shows, pure mother tongue instruction didn't improve achievement. It actually showed a slight decline. The bilingual approach worked. The monolingual approach, whether English or tree, didn't. Myth number 2. The problem with English medium instruction is the language. If we were to remove the language barrier, everything gets better. What the research shows, when you remove English entirely and teach only in tree, performance gets worse, but not better. So language is part of the issue, but it's not the whole issue. There's something about the bilingual approach that matters. Myth number 3. Secondary students should learn math in English because they're old enough to handle it. What the research shows is that students taught only in English showed almost no improvement. They were handling it well, but neither approach alone worked. The most effective approach combines mother tongue support with an English medium of instruction. You're not choosing between them, you're using them strategically. And here's a big implication about this finding. Most education debates are framed as either or. Should we teach English or mother tongue? Should we prioritize English proficiency or mother tongue literacy? But the research suggests the answer is it depends on what you're actually trying to accomplish, and you probably need both. And there's something important here for educators in Ghana specifically. The national policy says mathematics must be taught in English, but this research shows that it's not optimal. Students need the support of their mother tongue. The recommendations laid out by the findings of this research, quite frankly, requires more work of teachers. If they want to do right by their students and they read this study and they understand the findings, they'll have to learn how to strategically utilize the mother tongue as a consequential support system. It wouldn't be in the best interest of teachers to simply follow a textbook written in one language. You have to understand the concepts deeply enough to explain them in both. You have to know when to switch. You have to know which mathematical terms work better in which language, not just in Ghana, Here in the United States, this is a fugitive pedagogy. In some schools, the teachers would be reviewed poorly after a head of school classroom visit, or in the most extreme case, be let go because they used the language other than the official one, English. The moral of the story is bilingual instruction works. When students get the support, their achievement improves significantly. In this study, about 3 extra points, which might not sound like much, but in the context where students are starting at a 9.83 out of 20 points, that matters. And here's what also matters. The students who got the bilingual approach in the study started lower than the other groups. Remember, pre-test mean for that group was 9.83 compared to 12.22 for the English only and 13.52 for the TREAT only. So they were behind to begin with. And by the end, they caught up and made meaningful progress. If you're an educator in Ghana or anywhere with a similar situation, the research says, don't choose, integrate. Use mother tongue when students don't understand. Use it to build solid conceptual understanding. But don't abandon English. Your students need to be able to communicate mathematics in English for their exams, for their education, for their careers. And I want to push back gently on something. A lot of the mother tongue education advocacy frames this as a justice issue, and it is. Students shouldn't be excluded from learning because of language barriers. But the justice question is actually, how do we ensure students understand and can communicate effectively in the language of instruction? The answer is, based on this research, isn't to abandon English. It's to use it wisely, alongside the mother tongue as a formidable support system. This research shows that the real power isn't in replacing English with mother tongue. It's using both strategically. Pure approaches don't work. Integration does. That requires more thoughtful teaching. It requires teachers who can move between the languages. It requires materials and support for the bilingual approach. It's a lot of work, I know. But the payoff, students actually learn more. So the question isn't mother tongue or English. It's how do we use both to help students understand mathematics deeply and communicate mathematically effectively? Thanks for watching. If you're still here and you're an educator dealing with this directly, I'd love to hear what barriers you face. Is it a policy, resource, teacher training, your school principal? What would make a bilingual approach actually work in your context? Drop it in the comments. Until next time, Dr. Freeman out.